In this video, we are going to discuss sequences and series. So first, let's see what is a sequence. Sequence is a set of numbers arranged in a definite order. For example, a set of numbers 2, 4, 8, 16, 32, so on and so forth, 1024 is a set of numbers arranged in a definite order. Here, each number starting from the second one is twice its previous number. So it is a set of 10 such numbers. So it is a sequence of 10 numbers. We also can have a set of numbers, for example, successive quotients that we obtain in the division of 10 by 3 at different steps of division. In this process, we get 3, 3.3, 3.33, 3.333, and so on and so forth. Here, the numbers in the set are only 10, which is countable. Therefore, this sequence is a finite sequence, while the numbers in this sequence is infinite. Therefore, this sequence is called infinite sequence. So we have either a finite sequence or an infinite sequence. Each number in this sequence is called term of the sequence, which is denoted by either a1, a2, a3, etc., or t1, t2, t3, etc. Series is originated from sequence, and therefore if a1, a2, a3, so on and so forth, an be a given sequence, then the expression a1 plus a2 plus a3 plus so on and so forth plus an plus so on and so forth is called series associated with this sequence. This series may be finite or infinite depending upon the sequence, whether it is finite or infinite. In compact form, series are represented by sigma notation. Therefore, this series in sigma notation can be represented as sigma ak, where k goes from 1 to n. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. If nth term of a sequence an is n into n plus 2, then we have to find 5 successive terms of this sequence. Here we will put n equals 1, 2, 3, 4 and 5 and find out first term. A1 will be 1 into 1 plus 2, that will be 3. Second term A2 will be 2 into 2 plus 2, 4 2s are will be 8. Third term A3 will be 3 multiplied by 3 plus 2, that will be 5 3s are 15. Fourth term A4 will be 4 into 4 plus 2, 6 4s are 24. And fifth term A5 will be 5 into 5 plus 2, that equals 35. So the 5 successive terms of this sequence will be 3, 8, 15, 24 and 35. If nth term of another sequence Tn is 2 raised to n, we have to find 5 successive terms of this sequence. So the first term T1 will be 2 raised to n 2. Second term T2 will be 2 square 4. Third term T3 will be 2 cube 8. T4 will be 2 raised to 4 16. And fifth term T5 will be 2 raised to 5 32. So the 5 successive terms of this sequence will be 2, 4, 8, 16, 32. If we are given nth term an equals 4n minus 3, then how to find its 17th term? In place of this n, we have to put 17. So 17th term E17 will be 4 multiplied by 17 minus 3. 68 minus 3, that will be 65. So the 17th term of this sequence will be 65. What will be 9th term of the sequence an equals minus 1 to the power n minus 1? We will put 9 in place of this n. So nth term A9 will be minus 1 raised to 9 minus 1, that is 8. Even power of minus 1 is always plus. So the answer will be 1. We want to find seventh term of a sequence whose nth term is n square upon 2 raised to n. Here in place of this n we have to put 7. So the seventh term T7 will be 7 squared upon 2 raised to 7. That will be 49 upon 64. So this is how we can find particular term of a sequence or any number of successive terms of a given sequence. The Fibonacci sequence is defined by 1 equals a1 equals a2 and an equals an minus 1 plus an minus 2 for n greater than 2. Since n is greater than 2, we have to start with n equals 3, so that a3 will be a3 minus 1 a2 plus a3 minus 2 a1. That will be 1 plus 1 2. For n equals 4, a4 will be a3 plus a2, that will be 2 plus 1 3. For n equals 5, a5 will be a4 plus a3 equals 3 plus 2 5. For n equals 6, a6 will be a5 plus a4 5 plus 3 8. Here we have to find an plus 1 upon an for n equals 1 2 3 4 5. So for n equals 1, an plus 1 upon an will be a2 upon a1, that is 1 upon 1 1. For n equals 2, it will be a3 upon a2 2 upon 1 2. For n equals 3, it will be a4 upon a3 3 upon 2. For n equals 4, it will be a5 upon a4, that equals 5 upon 8. For n equals 5, it will be a6 upon a5, that will be 8 upon 5. So the sequence an plus 1 upon an will be this 1 2 3 upon 2 5 upon 8 and 8 upon 5. We will see what is nth term of an AP. If A is the first term and D is the common difference, then standard form of AP is A plus D, A plus 2D, so on and so forth. The nth term or the general term of AP is given as an or Tn equals A plus n minus 1 into D, where n is number of terms in AP. So let's block this formula. Next, L is the last term or the nth term of an AP. Then last term L will be an equals a plus n minus 1 into D, and sum of n terms of AP denoted by Sn will be n by 2 into 2a plus n minus 1 into D. Here putting a plus n minus 1 into D, which is this, equals L. We can also write sum of n terms of AP. Sn will be n by 2 into a plus this L. So we can find sum of first n terms of an AP either by this formula or by this formula, depending upon the known quantities. Income of a person in the first year is rupees 3 lakh and he receives an increase of rupees 10,000 to his income per year for next 19 years. We have to find total amount he receives in 20 years. Here we have rupees 3 lakh as the first term A. The increase per year rupees 10,000 is D and 20 years will be N. So for n number of years, the total amount will be Sn equals n by 2 into 2a plus n minus 1 into D, that will be 20 upon 2 into 2 times a, that is 3 lakh into 2 6 lakh plus 20 minus 1 19 multiplied by D is 10,000. That will be 10 multiplied by 6 lakh plus 1 lakh 90,000, which will be 10 multiplied by 7,90,000. So the total amount in 20 years will be S20 equals rupees 79 lakh. We have to find the sum of odd integers from 1 to 2001. The odd integers from 1 to 2001 will be 1, 3, 5, 7, so on and so forth, 1999, 2001. We have to find number of all these integers. We have here the first term a, 1, and the common difference d is 3 minus 1, that equals 5 minus 3, that equals 2. Now the last term Tn will be a plus n minus 1 into d. The last term Tn is 2001 plus 1 plus n minus 1 into 2. We will find out value of n. So it will be 2 times n minus 1 will be 2001 minus 1, 2000. N minus 1 will be 2000 upon 2, 1000. N will be 1000 plus 1, 1001. So there will be 1001 such terms which are odd integers from 1 to 2001. Now we have to find the sum of these 1001 terms, that will be n by 2 2a plus n minus 1 into d. So S of 1001 will be 1001 upon 2 into 2 multiplied by 1, that is 2, plus n minus 1, that is 1001 minus 1, 1000, multiplied by d, which is 2. So this will be 1001 multiplied by 2002 upon 2, 2 ones are 2 ones are. So this product will be 100,200,1. So this is the required answer, 100,200,1. The next problem is, in an AP, the first term is 2. So we are given a equals 2 and sum of the first 5 terms, that is S5 equals 1/4 the next 5 terms. We have to show that the 20th term is minus 112. So we have to show that the 20th term, that is 820, is minus 112. First we will find sum of first 5 terms, that is S5 equals 5 upon 2 multiplied by 2 times a, that is 4, plus n minus 1, that is 5 minus 1, 4 into d, that will be 2 2s are 4, 2 2s are 4, so 5 2s are 10 plus 5 2s are 10d. Now sum of next 5 terms will be sum of 10 terms minus sum of first 5 terms, S5. Now S10 will be equal to 10 by 2 into 2a, so that will be 2 2s are 4 plus n minus 1, that is 10 minus 1, 9d, minus S5, which we have found over here, so that will be minus 10 and minus 10d. It will be, this is 5, 5 4s are 20 plus 5 9s are 45d minus 10 minus 10d, that will be 20 minus 10, 10, 45 minus 10 plus 35d. Now from this equation 1 we write S5, which is this 10 plus 10d equals this 1/4 multiplied by sum of next 5 terms, which is 10 plus 35t. 4 into 10, 40, 4 into 10 plus 40d equals 1 into 10, 10, 1 into 35d, 35d. Now 40d minus 35d will be 5d equals 10 minus 40 will be minus 30. So that gives d equals minus 30 upon 5 minus 6. So we got a equals 2 and d equals minus 6. Now we can easily write the 20th term 820. So that will be 820 equals a, which is 2, plus n minus 1, that is 20 minus 1, 19, into d, which is minus 6. So it will be 2 minus 114. So that gives 820 equals this minus 112. We have to find how many terms of the AP minus 6, minus 11 by 2, minus 5, so on and so forth are needed to give the sum minus 25. We have to find this n. Here the first term a is minus 6 and the common difference t is minus 11 by 2 plus 6, that is minus 11 plus 12 upon 2, 1 upon 2. We have Sn equals n by 2 into 2a plus n minus 1 into d. That will be minus 25 equals n by 2. 2a 2 multiplied by minus 6 plus n minus 1 into d, which is half. That will be n by 2 multiplied by minus 12 plus half n, that is n by 2 minus half. That will be n by 2 into n by 2 minus 24 plus 1, 25 upon 2. That will be n by 2 multiplied by this 2 into n minus 25. So we get n into n minus 25 equals minus 25 multiplied by 4 minus 100. That gives n square minus 25n plus 100 equals 0. This can be factorized as n minus 20, n minus 5 equals 0. That gives n equals 20 or n equals 5. So these will be the two possible values of n, 20 or 5. So we shall need 20 terms or 5 terms to get the sum minus 25 of this AP. If sum of certain number of terms m of AP 25, 22, 19, so on and so forth is 106, we have to find the last term. For this AP, we have the first term a is 25 and common difference d is 22 minus 25 minus 3. We have sum of n terms Sn equals n by 2 into 2a plus n minus 1 into d. After putting the values, 116 equals n by 2 into 2a will be 2 multiplied by 25, 50 plus n minus 1 multiplied by d, which is minus 3. So from this we will get n. So it will be n times 50 minus 3n plus 3 equals 116 multiplied by 2, 232. This will be n multiplied by 53 minus 3n minus 232 equals 0. 53n minus 3n square minus 232 equals 0. That will be 3n square minus 53n plus 232 after changing the signs. Now this is a quadratic equation. We have to find two factors of this 3 multiplied by 232, 696, whose sum will be minus 53. Those two numbers will be minus 24, minus 29, whose sum will be minus 53. So we write 3n square minus 24n minus 29n plus 232 equals 0. Grouping the terms, taking 3n common, n minus 8 minus 29 into n minus 8 equals 0. So that will be n minus 8 multiplied by 3n minus 29 equals 0. That gives us n equals 8 or n equals 29 by 3. Since n should be a natural number, we will not take this value. So we have number of terms n is 8. Now the 8th term will be the last term. So last term a8 will be a plus 8 minus 1, that is 7d, which will be 25 plus 7 multiplied by d, which is minus 3. So a8 will be 25 minus 21, 4. So the last term will be the 8th term and that will be 4. In an AP, we are given that pth term is 1 by q, which means that AP is a plus p minus 1 into d, which is given to be 1 by q. We name this 1. Next, qth term is 1 by p, which means AQ equals A plus Q minus 1 D equals 1 by P. We name this 2. In order to eliminate A so that we will get equation in D, we will subtract second equation from the first one. So we change the signs. This will be minus, minus, and this will be minus. So A minus A will be 0 plus this will be PD minus D minus QD and minus minus plus D, which equals 1 by Q minus 1 by P. Now this D cancels with this D and we get, taking D common from these two terms, we get D into P minus Q equals, this will be P minus Q upon QP, that is PQ. Now this P minus Q cancels from both sides and we get D equals 1 upon PQ. Now in order to find the value of A, we will substitute the value of D in equation 1 and write A plus P minus 1 into D, which is this 1 upon PQ equals 1 upon Q. So now A becomes 1 upon Q minus P minus 1 upon PQ. That will be 1 upon Q minus P upon PQ will be 1 upon Q minus minus will be plus 1 upon PQ. 1 upon Q minus 1 upon Q is 0. So we get A equals 1 upon PQ. Now with the help of A equals 1 upon PQ and D equals 1 upon PQ, we write sum of first PQ terms as SPQ equals PQ upon 2 into 2A, that will be 2 upon this PQ plus N minus 1, that is PQ minus 1 into D, where D is 1 upon PQ. Now this will be PQ upon 2 into 2 upon PQ plus PQ into 1 upon PQ will be 1 minus 1 into 1 upon PQ will be minus 1 upon PQ. So that will be PQ upon 2. 2 upon PQ minus 1 upon PQ will be 1 upon PQ plus this one. So finally sum of first PQ terms will be half multiplied by PQ into 1 upon PQ will be 1 plus PQ into 1, that is PQ, which is this half into PQ plus 1. Next problem is, we have to find the sum of n terms of the AP whose kth term is 5k plus 1. Kth term of the AP is 5k plus 1, which means that AK is 5k plus 1. We have AK equals A plus n minus 1, that is here k minus 1 into D, where A is the first term, D is the common difference which we have to find out, equals 5k plus 1. This will be A plus dk minus D equals 5k plus 1, which we will write dk plus A minus D equals 5k plus 1. Now we will compare the coefficients of k, D and 5 and the constant term A minus D equals 1. So that gives us D equals 5 and A minus D equals 1. We will put the value of D over here and write A minus 5 equals 1. That gives A equals 6. Now we know value of D and value of A. So we will write the sum of n terms of the AP as Sn equals n by 2 into 2 into A, that is 2 into 6 plus n minus 1 into D, which is 5 here, that will be n by 2 into 12 plus 5n minus 5. So Sn will be n by 2 into 5n plus 7. Therefore the sum of n terms of the AP will be n by 2 into 5n plus 7. Next problem is, if the sum of n terms of an AP is Pn plus Qn square, where P and Q are constants, we have to find the common difference D. Sum of n terms of the AP will be Sn equals Pn plus Qn square. Now Sn, as we know, is n by 2 into 2a plus n minus 1 into d, which equals Pn plus Qn square. This will be n by 2 into 2a plus n into d nd minus d. That will be Pn plus Qn square. We will open the bracket. That gives n by 2 multiplied by 2a will be na, n by 2 multiplied by nd will be d by 2 n squared, n by 2 multiplied by minus d will be minus n by 2 d, that is Pn plus Qn square. This will be na minus n by 2 d, we will put this in bracket, plus d by 2 n square equals Pn plus Qn square. Now if we compare the coefficients of n square, which are d by 2 and q, so that gives us d by 2 equals q, that gives common difference d equals 2q. So 2q is the value of the common difference d. Next problem, the sum of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. We have to find the ratio of their 18th terms. Sum of n terms of two arithmetic progressions we will write as s1 upon s2, which equals this 5n plus 4 upon this 9n plus 6. Now we write s1 as n by 2 into 2a1, its first term, plus n minus 1 into d1, its common difference, upon, for s2 we write n by 2 into 2a2, its first term, plus n minus 1 into d2, its common difference, which equals 5n plus 4 upon 9n plus 6. Now since we have to find a ratio of their 18th terms, we will put this n equals 35 and see what happens. N by 2 cancels with this n by 2. It will be 2a1 plus 34d1 upon 2a2 plus 34d2, which equals 5 into 35 plus 4 upon 9 into 35 plus 6. So that gives 179 upon 321. Now if we divide both numerator and denominator by 2, we get a1 plus 17d1 upon a2 plus 17d2 equals 179 upon 321. We find that in the numerator it is the 18th term of first AP, and in the denominator it is 18th term of the second AP, which is 179 upon 321. That gives us the answer. Ratio of 18 terms of these two APs will be 179 is to 321. Next problem, if the sum of first p terms of an AP is equal to the sum of the first q terms, then we have to find the sum of the first p plus q terms. We write sum of first p terms of AP as SP, which is given to be equal to the sum of first q terms. We write it as SQ. So by using the formula, we write for SP p by 2 into 2a, where a is the first term, plus p minus 1 into d, where d is the common difference, which equals q upon 2 into 2a plus q minus 1 into d. Now this 2 cancels from both sides. Next we write p into 2a, 2pa plus p into d, pd into p minus 1, which equals q into 2a, 2aq plus q into d, qd into q minus 1. Next, we write 2pa minus this 2aq equals this qd into q minus 1 minus this pd into p minus 1. We will take 2a common and write 2a into p minus q equals, we will take this d common and write d multiplied by q into q minus 1 minus p into p minus 1. That will be d multiplied by opening the bracket, this will be q square minus q minus p square minus into minus plus p. That will be d multiplied by this q square minus p square can be factorized as q plus p multiplied by q minus p minus this q, and because of this minus sign, this plus sign will become minus, so q minus p. Now we will take this q minus p common and write d multiplied by q minus p multiplied by this q plus p and minus 1 for this q minus p. Now this d will be equal to this 2a multiplied by p minus q upon this q minus p we can write as minus p minus q by reversing the order of p and q and introducing this minus sign multiplied by this p plus q minus 1. Now this p minus q cancels with this p minus q and we get d equals minus 2a upon p plus q minus 1. So this is the value of d. Next we have to find sum of first p plus q terms, that we can write as s of p plus q, that will be p plus q upon 2 multiplied by 2a plus, in place of n minus 1 we write this p plus q minus 1 multiplied by d. Now we will replace this d by this value of d and write s of p plus q equals p plus q upon 2 multiplied by 2a plus p plus q minus 1 multiplied by this minus 2a upon p plus q minus 1. Now we can cancel this p plus q minus 1 with this p plus q minus 1 and we get p plus q upon 2 multiplied by this 2a minus 2a, that will be 0. So therefore sum of first p plus q terms will be 0, and this is what we have to find out. Next problem, the ratio of the sums of m and n terms of an AP is m square is to n square. We have to show that the ratio of mth and nth term is to m minus 1 is to m minus 1. First we will write ratio of sum of m and n terms. So Sm upon Sn equals m square upon n square given. Now we write Sm as m upon 2 into 2a plus m minus 1 into d upon, for Sn we write n by 2 into 2a plus n minus 1 into d equals m square upon n square. We will cancel this 2 from numerator and denominator and cancel this m from this m square and this n from this n square and write 2a plus m minus 1 into d upon 2a plus n minus 1 into d equals m upon n. Now we have to show the ratio of mth and nth term to be equal to 2m minus 1 is to 2n minus 1. So that we can obtain by substituting this m by 2m minus 1 and this n by 2n minus 1. Let us see what happens next. We will get 2a plus 2m minus 1 minus 1, that will be minus 2 into d upon 2a plus 2n minus 1 minus 1 minus 2 into d equals, for this m also we write 2m minus 1 and for this n we write 2n minus 1. We will take 2 common from numerator and denominator and write 2 multiplied by a plus 2m minus 2 will be m minus 1 into d upon 2 multiplied by this 2a will be a plus this 2n minus 2 will be n minus 1 into d equals 2m minus 1 upon 2n minus 1. Let's cancel this 2 from numerator and denominator. Now this a plus m minus 1 into d is nothing but the mth term of AP upon this a plus n minus 1 into d is nothing but nth term of the AP. So which equals 2m minus 1 upon 2n minus 1. So that proves ratio of mth term and nth term of this AP is 2m minus 1 is to 2n minus 1 as required here. Next problem, if the sum of n terms of an AP is 3n square plus 5n and its m term is 164, we have to find the value of m. Sum of n terms of AP is 3n square plus 5. This we write as Sn equals 3n square plus 5n. That will be n by 2 into 2a plus n minus 1 into d equals 3n square plus 5n. Next, n by 2 multiplied by 2a will be na plus n minus 1 n by 2 multiplied by d will be nd by 2, that equals 3n square plus 5n. Next, na plus this will be d by 2 n into n square minus 1 into nd upon 2 minus nd upon 2 equals 3n square plus 5n. We write this as d upon 2 n square plus, taking n common from these two terms, we write a minus d by 2 multiplied by n equals 3n square plus 5n. Now comparing the coefficients of n square, we write d upon 2 equals 3, that gives us d equals 6, and comparing coefficient of this n, we write a minus d upon 2 equals 5. So a minus d upon 2 equals 5. Now we will substitute the value of d here, so it will be a minus 6 upon 2 will be 3 equals 5. So that gives a equals 8. So we got a equals 8 and d equals 6. Next, we have been given that its mth term is 164, which means am is 164. We write am as a plus m minus 1 into d equals 164. Now here we will substitute the values of a and d from here and write 8 plus m minus 1 into d, which is 6, equals 164. So 6 into m minus 1 will be 164 minus 8, that will be 156. So m minus 1 will be 156 upon 6. 6 ones are 6 twos are 12, 6 sixes are 36. So that gives m equals 26 plus 1, 27. So this is the value of m, 27. Next problem, if a raised to n plus b raised to n upon a raised to n minus 1 plus b raised to n minus 1 is the arithmetic mean am between a and b, then we have to find the value of n. The arithmetic mean between a and b will be a plus b upon 2, which is given to be equal to a raised to n plus b raised to n upon a raised to n minus 1 plus b raised to n minus 1. By cross multiplication, we write a plus b multiplied by a raised to n minus 1 plus b raised to n minus 1 equals 2 times a raised to n plus b raised to n. Now a multiplied by a raised to n minus 1 will be a raised to 1 plus n minus 1 plus a into b raised to n minus 1 will be a b raised to n minus 1 plus b into a raised to n minus 1 will be b a raised to n minus 1. Then b into b raised to n minus 1 will be b raised to 1 plus n minus 1, that equals 2 times a raised to n plus b raised to n. This will be a raised to n plus a b raised to n minus 1 plus b a raised to n minus 1 plus b raised to n, that will be 2 times a raised to n plus b raised to n. These two terms, a b raised to n minus 1 plus b into a raised to n minus 1, that equals 2 times a raised to n plus b raised to n. We will take sum of a raised to n and b raised to n to the right side, which becomes minus a raised to n plus b raised to n. This will be 2 minus 1, that is a raised to n plus b raised to n. Now this b a raised to n minus 1 minus this b raised to n equals this a raised to n minus this a b raised to n minus 1. We write this as 2 minus 1, that is a raised to n plus b raised to n. Now we will send this b raised to n to the left side and this b into a raised to n minus 1 to the right hand side, and write a b raised to n minus 1 minus b raised to n equals this a raised to n minus this b a raised to n minus 1. Now we will take b raised to n minus 1 from these two terms and write b raised to n minus 1 multiplied by a minus b equals, we will take a raised to n minus 1 from these two terms and write a raised to n minus 1 multiplied by a minus b. Now this a minus b cancels from both sides and we get b raised to n minus 1 equals a raised to n minus 1. We will divide this a raised to n minus 1 by b raised to n minus 1. That gives us a raised to n minus 1 upon b raised to n minus 1 equals 1. This we write as a upon b raised to n minus 1 equals 1, which equals a upon b raised to 0, because a upon b raised to 0 is 1. Now from these two terms we get n minus 1 equals 0, gives us n equals 1. So this is the value of n for the numbers between 1 and 31 and the m numbers between them. So the AP will be 1, A1, A2, A3, so on and so forth, AM, and finally it will be 31. Now in this AP, the first term A is 1 and the nth term AN is 31. Total number of terms in this AP, that is n, will be these m numbers plus this 1 and this 31, that is 2. So total number of terms will be m plus n. Now we have an is equal to a plus n minus 1 into d. So we write an 31, that equals a, which is 1, plus n is m plus 2 minus 1 into d. This will be m plus 1 into d equals 31 minus this one, it will be 30. So we get d equals 30 upon m plus 1. In terms of first term a and common difference d, we can write this AP as a plus t, a plus 2d, so on and so forth, 31, so that a1 will be a plus t and hence a2 will be a plus 2d and hence a7 will be a plus 7d and m minus nth term will be a m minus 1, that is a plus m minus 1 into d. Now the ratio of 7th and m minus 1th term is 5:9, which we can write as a7 upon a m minus 1 equals 5 upon 9. That will be a plus 7d upon a plus m minus 1 t equals 5 upon 9. Now we will substitute the values of a and d and write 1 plus 7 multiplied by value of d, which is 30 upon m plus 1 upon 1 plus m minus 1 multiplied by 30 upon m plus 1, which is 5 upon 9. And now this will be 1 plus 7 into 30, 210 upon m plus 1 upon 1 plus m minus 1 into 30, 30m minus 30 upon m plus 1 equals 5 upon 9. That will be 1 into m plus 1 plus 210 upon m plus 1 upon 1 into m plus 1 plus 30m minus 30 upon m plus 1, that equals 5 upon 9. Now this m plus 1 cancels with this m plus 1. Now cross multiplying 9 multiplied by m plus 211 equals 5 multiplied by m plus 30m, 31m, 1 minus 30 minus 29. This will be 9m plus 1899 equals 5 into 31, 155m minus 145. 155m minus 9m will be 146m equals 1899 plus 145, that will be 2044. So therefore m will be 2044 upon 146, that gives m equals 14. So this will be the value of m. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.